question, we're given 4 numbers as input. Let those 4 numbers be labeled x1, v1, x2, and v2 respectively. In this case, x1 and x2 are starting positions of 2 kangaroos, say k1 and k2. v1 and v2 are the distances that k1 and k2 cover at each jump respectively. The task is to find out whether or not k1 and k2 will ever meet if they start jumping from x1 and x2 respectively. Explanation with example. Suppose we get the following input, 0, 3, 4, 2. In this case, x1 equals 0, v1 equals 3, x2 equals 4, and v2 equals 2. Thus, the kangaroo k1 starts from 0 and after each jump, moves ahead by 3 meters. And the kangaroo k2 starts from 4 and moves ahead by 2 meters. Let's tabulate the progress of each kangaroo at every jump to understand whether or not they'll ever meet. Thus we can see that on the 4th jump, both the kangaroos k1 and k2 meet at the same position. The same can be illustrated by the following image. So in this case, the output should be yes. Solution explanation. Naive solution. The most straightforward solution to this problem would be to run a while loop as long as the kangaroo which starts from a lesser value is at a position less than or equal to that of the kangaroo starting from a higher value, while both of them are jumping. The code will look like this: _kangaroo equals min, x1, x2, _kangaroo equals max, x1, x2, while, _kangaroo equals _kangaroo make _kangaroo jump make _kangaroo jump, if _kangaroo equals _kangaroo then yes else no. However, this is not a good solution, and moreover, if the _kangaroo covers more distance than the _kangaroo at each jump, then the control will fall into an infinite loop. To prevent that, the following extra check must be added before the while loop. If x2 x1 and v2 v1 then no. Optimized solution. To write the most optimized solution to this problem, let's first form an equation with the given variables. We have x1 equals starting position of kangaroo 1, v1 equals distance covered by kangaroo 1 in each jump, 2 equals starting position of kangaroo 2, v2 equals distance covered by kangaroo 2 in each jump. Let's suppose that after n jumps, kangaroo 1 and kangaroo 2 meet. Therefore we see, starting position of kangaroo 1 plus n times the distance covered by kangaroo 1 in each jump equals starting position of kangaroo 2 plus n times the distance covered by kangaroo 2 in each jump. This is because we assume that both the kangaroos meet after each of them jumps n times. Thus, we get the following equation: x1 plus nv1 equals x2 plus nv2. Let's rewrite the equation to get the value of n. x1 plus nv1 equals x2 plus nv2 equals nv1, nv2 equals x2, x1 equals n, v1 v2 equals x2, x1 equals n equals x2, x1, v1 v2, required equation. Now, this is only possible when n is a whole number, i.e., an integer that is greater than or equal to 0. This is because the kangaroos cannot jump backward, n0, rejected, and the kangaroos cannot make partial jumps, n is strictly an integer. Thus, we can calculate the value of n using the given input data, and if n is a whole number, we return yes, otherwise, we return no. However, in case both the kangaroos start from the exact same point and cover the same distance in each jump, we can directly say that they will meet. Thus, we can directly return yes in that case. In case only v1 equals v2, i.e., both kangaroos cover the same distance in each jump but do not start together, we can directly say that they will never meet as the distance between them is always constant. We have to check for this condition before the program tries calculating the value of n and returns no. As otherwise, if the program tries to calculate the value of n in this case, the denominator becomes 0, and the division by 0 exception will get raised. Keeping the above points in mind, the optimized solution to the problem is given below. The solution is provided in Python, Java, C++, and C, in the link to the article provided in the description below.